All right, let's get right into it. Inside every single device you own, your phone, your laptop, your smartwatch, there's a tiny little brain called a processor. And at the very heart of that brain is a fundamental design choice. You could even call it a philosophical battle that has shaped pretty much the last 40 years of technology. We're talking about RISC versus CISC, the two major competing ideas on how a computer should actually think. But before we dive into all the techie stuff, let's start with a really simple question. When you're faced with a complex task, how do you personally approach it? Are you the type of person who looks for one super sophisticated, multi-purpose tool that can handle everything at once? Or do you prefer to have a whole set of simple, specialized tools where each one just does a single job but does it perfectly? Your answer to that question, well, it gets right to the heart of this entire debate. And this right here, this is the perfect analogy for these two core philosophies. On one side, you've got the Swiss Army knife, one complex tool that's designed to do a whole bunch of different things. And on the other, you've got the specialist's toolkit, a collection of simple, super efficient tools, each one designed for just one specific purpose. Definitely keep this image in your head because it is the key to understanding everything we're about to cover.
So, let's start with the Swiss Army knife of the computing world, CISC. You can think of this as the traditional approach, the powerhouse philosophy that really dominated early computing. And it's still what runs most of the desktops and laptops we all use today.
CISC stands for Complex Instruction Set Computing. And honestly, the name says it all. The goal here is to create a processor that understands a huge complex vocabulary of commands. Think of it like a processor that's fluent in a really rich language, one that's able to understand very nuanced, multi-part instructions. Okay, so here's the crucial point. CISC was originally designed to make life easier for human programmers, especially way back in the day when memory was incredibly expensive and compilers just weren't very smart. With CISC, a single command could kick off a whole chain of operations, like fetching data from memory, doing a calculation, and storing the result, all in one go. So what's the trade-off? Well, all that complexity is built directly into the hardware, and these powerful instructions can take several ticks of the processor's internal clock to get done. But then, a totally new philosophy came along, a challenger that looked at this exact same problem from a completely different angle. And that brings us to the specialist toolkit, RISC. Yep, this is RISC, which stands for Reduced Instruction Set Computing. Now, that word reduced might sound like a bad thing, like a downgrade, but in this world, it's actually the secret to incredible speed and efficiency. Instead of teaching the processor this massive, complex language, the RISC philosophy says, hey, let's give it a very small, simple, and highly optimized vocabulary.
So the focus completely shifts. It's no longer about making things easy for the human. It's all about making things lightning fast for the machine. Every single instruction does one and only one simple thing. This simplicity means the hardware itself can be much, much less complex. The real brains of the operation get moved to the software, specifically the compiler, which is now responsible for breaking down big tasks into all these simple, bite-sized instructions. And the ultimate goal? To execute every single one of those instructions in just one tick of the clock.
Okay, so we've got two very different ways of doing things. The complex, do-it-all Swiss Army knife versus the simple, focused specialist's toolkit. Let's actually put them head-to-head with a real example to see how they differ in practice.
We're going to give both of our processors a super basic task: multiply two numbers together. It's a simple operation for sure, but it really shows the profound difference in how they work.
So the CISC processor, with its huge vocabulary, has a specific command for this, multiply. You just give it that one single command, and the complex circuitry inside the chip just takes over. It handles everything, fetching the numbers, doing the math, storing the result. One instruction, and the job is done. It's really elegant and simple from the programmer's point of view.
Now, the RISC approach? Totally different. It doesn't have a single complex multiply command. Instead, the compiler breaks that task down into its most basic parts. There's an instruction to load the first number, another to load the second number, a third one to actually do the multiplication, that's the prod, and finally a store instruction to put the answer back into memory. Sure, it looks like more steps, but each individual step is incredibly simple and blindingly fast.
This table really sums it all up perfectly. CISC, large, complex instruction set, takes multiple clock cycles, and all the heavy lifting is in the hardware. RISC, small, simple set, aims for a single clock cycle and shifts the complexity to the software.
And that last point, pipelining, that's a huge deal. Because RISC instructions are all so simple and uniform, the processor can line them up like an assembly line, starting the next instruction before the last one is even totally finished. That's way harder to do with CISC's weirdly shaped, complex commands.
Okay, so this is all really interesting from a technical perspective, but why does this whole battle of architectures actually matter to you? Well, it pretty much determines the kind of performance and efficiency you get from the devices you use literally every single day.
Here it is, the core trade-off. CISC processors are the champions of raw, brute force performance. They're designed to just power through complex tasks. But all that complex hardware, it eats up a lot of power and generates a ton of heat. RISC, on the other hand, is the absolute master of efficiency. It delivers incredible performance per watt, which makes it perfect for any device where your battery life is everything.
And that trade-off maps directly to where you find these chips. Your power-hungry desktop gaming rig, your work laptop, that's almost certainly running a CISC processor, probably from Intel or AMD. But that device you're likely holding in your hand right now, your smartphone, your tablet, your smartwatch, that is the kingdom of RISC, totally dominated by designs that put battery life first.
But, and this is really important to understand, in the modern world, this isn't some kind of holy war anymore. The lines have gotten really blurry. A lot of modern CISC processors actually translate their own complex instructions into simpler, RISC-like commands internally, just so they can take advantage of things like pipelining. And at the same time, RISC processors have been adding more complex instructions to get an extra performance boost. They're basically just borrowing the best ideas from each other.
And all of this leaves us with a really fascinating question for the future, doesn't it? As artificial intelligence demands massive amounts of processing power and our mobile devices crave more and more performance without killing the battery, which approach is going to win out? Will it be the raw power of the complex approach, the lean, mean efficiency of the reduced approach, or maybe some new hybrid philosophy that we haven't even thought of yet? The battle inside your processor, well, it's far from over.